Hi, my name is Akshat, and I'm a second-year graduate student, and I've been with Anne Sickles' group for almost a year and a half, 2 years now. I'm originally from India, but then I did my undergrad in New York, and then I came to University of Illinois. It's been great. I work on the ATLAS collaboration, and currently I'm working on my qualification task to get my name on ATLAS papers. On a daily basis, my work involves a lot of coding. It's C, C++, a little bit of Python thrown in. I mostly work with the ATLAS software is a big beast that, it's again, since it's a big collaboration, everything was built in-house, and it's a lot to understand, and that's where also Anne comes in. Like she knows a lot of this stuff, and our postdoc also knows a lot of this stuff, so it's always helpful to have them around. But on a daily basis, I work with the ATLAS software. So I actually went to CERN for the Heavy Iron Run in December of 2015, and it was a lot of fun. It was a lot of work. It was a lot of fun. I was there for about 3 weeks. And there was a heavy iron run was going on, so you were bang in the middle of the action. And the great part about that was that when you're sitting here so far, you don't really get to know the scale of these things, but when you go there, you see the whole back end and how the data is collected, and you can potentially get to see the cavern, which is this huge, one of the biggest man-made caverns, and the detector is like massive, 20 meters wide, 44 meters long, and it's just an amazing thing to be a part of. There's this incredibly hot and dense matter called the coagulant plasma that was at the beginning of the Big Bang, and that's how the universe started. And so we are investigating jets, which is sprays of particles coming out from that plasma. We're using jets as a tool to study that plasma. The detector measures all sorts of energies and energies and voltages, and we use the software to analyze those energies. And like in the example of jets, the most basic thing that we do is we look at the two sprays of particles that are coming out in opposite directions, and the momentum has to be conserved, but if you see one spray of particle having less energy or momentum than the other one, then you know that something happened, and that tends to happen if that spray of particles is coming from inside this matter that we call the coagulant plasma. I chose the University of Illinois because initially I'd planned to come into condensed matter, and there's no place better than U of I for condensed matter. The fact that this is such a big university, it has a lot of diversity in terms of not only its population, but also in terms of what is available for you to do. And there's all sorts of student organizations and other organizations that you can be a part of to get your extracurricular activities done, and just to get away from physics or whatever your core area is, which everyone needs just to be sane.